Alright, January 2018, question 11c. We're told that A is the matrix minus 1, 3, 0, 2. B is the matrix minus 3, 1, 4, 2, 1, 6. The first thing we're asked to do is to do what? First thing we're asked to do is to do what? Help me please. Determine A inverse. We're asked to find A inverse. Now A inverse is equal to 1 over the determinant of A times adjoint A. A inverse is equal to 1 over the determinant of A times adjoint A. Alright, let's find the determinant of A. The determinant of A is this times this. So it's minus 1 times what? 2 minus this times this. So it's what? 0 times what? 3. This is minus 2. What is 0 times 3?
0.
What is minus 2 minus 0? What is minus 2 minus 0? Is what? Minus 2. If you add 0, you can't. If you add 0 or take away 0, it doesn't make a difference. You understand? So the answer, the determinant is what? The determinant is what? Did you get that?
Yes.
No. So A inverse would be 1 minus 2. 1 over minus 2, which is the same as saying what? Minus a half. Now, times what? A adjoint. Adjoint A. So, how do you get adjoint A? You're going to switch these around, don't it?
Yes.
So this is what? 2 minus 1. These two stay where they are, but their what? Signs change. So this is minus 3, and this is what? 0. You don't say minus 0. Understand? 0 don't understand. Minus 0 plus 0 is still just what? 0. This is what? Remember I know. I'm going to multiply everybody inside here, so by what? Negative a half. So this is what? A negative times a positive is a what? So this is what? Minus 2 over 2. Minus 2 over 2. This is what? Minus 0 over 2. Or we can just go straight and say 0. And negative, sorry, what is minus a half times 0?
0.
Still 0. A negative times a negative is a what?
Positive.
Positive what? 3 over 2. A negative times a negative is a what?
Positive.
1 over 2. Multiplying by a half is the same as saying what? Divide by 2. Multiplying by a half is the same as saying divide by 2. This is minus 1, 3 over 2, 0 and a half. This is A inverse. What did they say next? Show that what?
A inverse is identical to I.
It says what?
The identical matrix.
Alright, 3 don't make no sense. Determine the matrix what? A inverse? That don't make no sense. Did anybody did anybody look at it and see what it was actually saying? There's the third one. No, it should be determined what? A squared. It should be determined the matrix A squared. Alright. Show that what? A inverse times A is equal to I. You wanted to ask a question? What is it? Huh? A times A inverse equal to I. Where we don't know. This is just I. We'll find A inverse. Now we're asked to show that what? A inverse times A is equal to I. A inverse. If I'm going to use A inverse, I would use this version of it. I wouldn't use this version. I would use this version. I could use it, but I wouldn't. I would use this version of it. So it's minus a half. Then what? 2 minus 3, 0 minus 1. This is A inverse. Multiplied by A. A is what? Minus 1, 0, 3, 2. What I'm going to do first, I'm going to multiply the two matrices. So write back the fraction minus a half. Now, when we're multiplying two matrices, we multiply what? The rows of the what? First matrix by the columns in the second matrix. Whenever we multiply a row by a column, we get a value. Whenever we multiply a row by a column, we get a value. So if I multiply the top row by the left column, I'm going to get the top left value. How do we multiply a row by a column? First element in the row, first element in the column. Second element in the row, second element in the column. Watch me. So I'm going to put that over it. So it's this times this times that. What is 2 times minus 1? Plus 0 times 3. Let me know. I just multiply the top row by the left column. Now I'm going to multiply the top row by the right column. Switch over to the right column. First element in the row, first element in the column. Second element in the row, second element in the column. What is 2 times 0?
0.
0 times 2.
0.
I'm going now to the bottom row. Left column. First element in the row, first element in the column. Second element in the row, second element in the column. I'm multiplying the bottom row by the left column, so I'm going to get the bottom left what? Value. A negative times a negative is a what?
Positive.
3 times 1.
3.
A negative times a positive is a what?
Negative.
Minus 1 times 3.
Negative.
Move over now to the what? Right column. What is minus 3 times 0? What is minus 3 times 0?
0.
What is minus 1 times 2?
Minus 2.
Alright. Switch back. This now becomes what? Minus a half. This is minus 2, 0, 0, minus 2. Do you agree? Do you agree?
Yes, sir.
Multiplying by a half is the same as saying what? Divided by 2. A negative times a negative is a 2 over 2. 0, 0. Negative times a positive is a what? Negative times a negative is a what?
Positive.
2 over 2. This is equal to what? 1, 0, 0, 1. 1, 0, 0, 1 is what? 1, 0, 0, 1 is I, which is the identity matrix. The examiner is asking us to show that A inverse times A is equal to I. We have done that. We have done it before. We know how to do it. Next, determine A inverse. Determine A inverse. Triple I.
A squared.
A squared, thank you. A squared. Now, A squared means what? A multiplied by A. So, literally, we're multiplying what? A, which is what? Minus 1, 3, 0, 2, multiplied by what? Minus 1, 3, 0, 2. Ladies and gentlemen, we're multiplying two matrices. How do we multiply two matrices? We multiply the rows of the what? First matrix by the what? Columns in the second matrix. How do we multiply a row by a matrix? A row by a column? First element in the row, first element in the column. Second element in the row, second element in the column. So 1, 2, 1, 2. Equal. Negative times a negative is a
Positive.
1 times 1.
1.
0 times 3.
0.
Move over to the right column. Minus 1 times 0. 2 times 0. Bottom row, left column. 3 times minus 1. Help me now.
-3.
Minus 3. 2 times 3.
6.
Move over now to the right column. 3 times 0.
0.
2 twos.
4.
Did you get 1, 3, 0, and 4?
Yes, sir.
Ladies and gentlemen, that is A inverse. That is
square.
A square. Thank you. That's not what is there. I wrote that in error. What should it say is matrix A squared. Alright. Explain why the matrix AB is not possible. You tell me. Why is the matrix AB not possible? Why is the matrix AB not possible? AB is not compatible for multiplication. Two matrices are compatible for multiplication when the number of columns in the what? First matrix is equal to the number of what? Rows in the second matrix. Now A is a
2 by 2.
2 by 2 matrix. This is what? Row and what? Column. B is a what?
3 by 2.
B is a
3 by 2.
3 rows and what? 2 columns. This is what? 3 by what? 2. So this is what? Over here is what? Row and here is what? Column. What is the number of columns in the first?
2.
The number of columns in the first is 2. What is the number of rows in the second?
3.
3. This fact make them what? Not compatible for multiplication. Two matrices are compatible for multiplication when the number of columns in the what? First matrix is equal to the number of rows in the what? Second matrix. So then we can further say the number of columns, in first matrix, 2, the number of columns is what? 2, is not equal to, the symbol, is not equal to the number of rows in the second. Number of rows is what? 3 in the second matrix. The man said I should explain why. I think if you write that, that is sufficient. Two matrices are compatible for multiplication when the number of columns in the first is the same as the number of rows in the second. Here, the number of columns in the first is what? 2. The number of rows in the second is what? 3. They are not the same, therefore they are what? Not compatible for what? Multiplication. It's amazing, you know, what we take for granted. When we probably learn this, we probably think that this part of it wasn't important. What did they say last?
Without calculating, state the order of the matrix product.
Alright. Now, lastly, this is B. Without calculating, state the value of the matrix product what? BA. So this is not AB now, this is what? BA. Here's the issue. AB was not possible, but BA is possible. B is a what? 3 by what? 2 matrix, don't it? I am multiplying it by A, which is a what? A 2 by 2 matrix. This is the number of what? Rows and what? Columns. Rows and what? Columns. What is the number of columns in the first matrix? Let me know. What is the number of rows in the second matrix? So you see this made them compatible. The number of columns in the first is equal to the number of rows in the what? Second. This makes them what? Compatible. I would have told you that. Now, here's what they're asking us. Without doing the actual calculation, what is the order of the matrix product BA? Alright? It's the number of rows in the first, which is what? 3. By the number of columns in the what? Second, which is what? 2. This is the what? Order of matrix product. This is what? BA. The order of matrix product BA is what? 3, 2. In other words, BA is a 3 by 2 matrix. BA is a 3 by 2 matrix. Ladies and gentlemen, two matrices are compatible for multiplication when the number of columns in the first is equal to the number of rows in the second. The number of rows in the first by the number of columns in the second is the order of the what? Resulting matrix. The number of rows in the first by the number of columns in the second is the order of the resulting matrix. This is what the examiner wanted us to do.